International Mathematics Competition for University Students 1996, problem 2, and this was for 10 points. Despite being from the repeated competition problem, it's not that tough. Yeah, it's somehow simpler. First of all, seeing this expression, and this one over here is actually an even function. Yeah, that's why we can think of using King's rule to simplify this expression, because over here we from King's rule. If you don't know about King's rule, first let me share that. Yeah, okay. Now first let me share that integral from a to b of f of x dx. This is actually equal to integral from a to b of f of a plus b minus x dx. You can get this from a simple u substitution. Yeah, and with that, here a plus b minus x is pi minus x. Yeah, so basically f of x, the integral of f of x is equals to integral of f of minus x in this case. So this should be equals to integral from minus pi to pi. This overall it's even function. Basically we get minus sine nx by minus sine x, and this cancels each other out. And over here we get 2 to the power x by 2 to the power x plus 1, isn't it? Because this is minus x, and so we get this expression dx. Yeah, now both of them are I of n, and if we add these two, there's gonna be some sort of simplification. 2 times I of n is integral from minus pi to pi. You can take this expression common, sine nx by x. Yeah, and the other is over here. We can take 1 plus 2 to the power x as common. Over here there's 1, and over here there's 2 to the power x. Yeah, and dx. Now this cancels out, and so we get 2in is equals to integral from minus pi to pi of sine of nx by x dx. And now since we know that this expression over here is even, we can write this as 2 times integral from 0 to pi of sine of nx by x dx. Yeah, and now 2 to cancel each other out, so we get I of n is equals to integral from 0 to pi of sine of nx by x dx. Now how do we proceed further? Now, just like I did in my previous video, these trigonometric stuffs, if we can try to use recursive, I mean we can try to use recursion, and if we try to use the sum of, let's say, I of n plus 1 and I of n minus 1, yeah, or sum or difference, anything as such. These trigonometric stuffs, the sum or difference will change to products, and if you take n plus 1 and n minus 1, their sum by 2 will just be n, and difference by 2 will just be 1. Yeah, and these stuffs will be similar to what we have originally. So there will be simplified versions which will be easier to deal with. So let's see how does it go. So basically now if we try to find I of n plus 1 minus I of n minus 1, let's say, we get integral from 0 to pi of sine of n plus 1 x minus sine of n minus 1 x, yeah, by x dx. We get this expression, yeah. Now for this we know that this over here is equal to 2 times cos of their average of the sum. Sum is 2n, and by 2 is nx, 2nx, and now their difference is 2x, and by 2 is x, sin x Oh, I think I forgot something. Here it was sine, isn't it? I'm sorry for that. I'm sorry for that. Yeah, here. Oh, I've been missing it for so long. I'm sorry, I'm sorry. I'm sorry for that. I'm sorry for that. I'm sorry for that. Now it's fine, I guess. Okay. And now they cancel each other out. So now this problem is pretty easy. Integral from 0 to pi of cos of nx dx, and we know that this integral is sine nx by n, and from 0 to pi that's just 0. Yeah. So this is actually cos 0. This implies that I of n plus 1 is equals to I of n minus 1, which can also be written as I of n is actually I of n minus 2. This implies that if n is even, in that case I of n will eventually equal to I of 0, and if n is odd, in that case I of n will eventually be equal to I of 1. So we now just need to find I of 0 and I of 1, and that will solve the problem. Now over here in this one, I of 0 will be integral from 0 to pi, and sine of 0x is 0 by sine x. Yeah, 0 by sine x dx. And now we know that this is just 0. And I of 1 is equal to integral from 0 to pi of sine x is just 1 dx, and this is just pi. So I of 0 is 0 and I of 1 is pi. So that's why our integral I of n is equals to 0 if n is even, and is equals to pi if n is odd. Yeah, and that's it. We have solved the problem from the international mathematics competition for university students. Yeah, so this problem was not that hard, I should say. Yeah. So first of all, we just use King's rule, and later on we just use some recursive ideas. Yeah, and that's all the problem. So first of all, we used the King's rule, and these two added up, which simplified the problem. And then we took in plus 1. Like basically, I had also tried plus sign over here, and that didn't work, so I just took minus sign. I did that myself, but here I just did the correct stuff. And then it simplified the difference, so this will be equal. And yeah, that does solve the problem. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.